Hello everyone, I am Chelma Reddy. Welcome to CR Maths class. Today I am going to explain matrices concept. Now, what is the definition of matrix? If you know very well, for suppose 10 students have written exam. So the exam is conducted uh, for suppose 10 marks question paper. One of the student he will get 10 out of 10. Another student he will get the 9 marks, 8 marks, 7 marks, 6 and so on. 1. Some of the students they will get 0 and a negative also. If it is their negative mark. Okay. Now those list of the marks we can arrange in the form of rectangular arrow, either open bracket or closed bracket. For suppose I am taking this is a open bracket. This is a rectangular arrow. So the marks can be assigned here either horizontal lines and vertical lines. So finally we will say that this is the matrix. Generally, what is the definition means? If the complex numbers can be arranged in the form of a rectangular arrow consisting of the complex numbers in horizontal lines and vertical lines. This arrangement is called matrix. This arrangement is called matrix. So the numbers are called the elements of the matrix or entries of the matrix. So horizontal lines are called, these are called rows. Vertical lines are called columns. These are columns. Now, how to count that in that matrix? How many rows are there? How many columns are there? Rows counted from top to bottom, like this. Top to bottom. This is R1 row. This is R2 row. This is R3 row. This is R4. Rows are counted from top to bottom. Columns are counted from left to right. This is first column. This is second column. This is third column. This is fourth column. For suppose you have 4 elements. For suppose 1, 2, 3, 4 elements. By using these 4 elements, we want to form the matrix. That is 1, 2, 3, 4. So this is not correct. Here horizontal line is there, but vertical lines also need. Here these two places there is no element. That's why we can write 1, 2, 3, 4. So here horizontal lines and vertical lines. So we can write 1, 2, 3, 4 also. This is completely one horizontal line, 4 vertical lines. Okay, so the rows and columns, so we can fill each and every place. Then only we will say that that is a matrix. So once again, listen. What is the definition of matrix means? A rectangular arrangement of numbers. Those numbers are either real numbers or complex numbers in rows and columns is called a matrix. The arrangement is enclosed by open bracket. This is open bracket or closed bracket. Any bracket you can take, no problem. So in that matrix, we are filling the numbers now. These numbers are called, we will say that elements or entries of the matrix. Next, how to find that order of the matrix? Order of the matrix. A matrix having m rows, n columns. A matrix having m rows and n columns is called a matrix of m by n, or simply it can be read as m by n. Don't read m into n. Can be read as m by n. A matrix A of order m by n is usually written in the following manner. Or otherwise, I will give one example. See here, let A be the matrix. Here, 1, 2, 3, 4, 5, 6, 7, 8. Students, here observe that how many rows are there. Rows, how to count? Top to bottom. This is R1 row. This is R2 row. There are two rows. How many rows are there? Two. Number of columns. Columns are counted from left to right. This is C1, C2, C3, C4. Overall, how many columns are there here? Four columns. So matrix order means how to write? Rows by columns. Now here, A matrix order, there are two rows and three columns. So matrix order is 2 by 3. 2 by 3. Here, m by n matrix given. There are m rows and n columns. See here, this is first row, second row, third row, and so on, m rows. Now this is first column, second column, third column, and so on, nth column. So here there are m rows and n columns. Order of the matrix is m by n. Here observe that one of the element A23. A23 meaning is the element A is in the second row, third column. Second row, third column. For suppose A1n, that means first row, nth column. The element is first row, nth column. If Aij, this is ith row, jth column element. Aij is ith row, jth column element. Okay. Now, here see that in a compact from the above matrix is represented by A is equal to Aij, m by n matrix. There are m rows and n columns. A11, A12, and so on. These are known as elements of the matrix A. Elements of the matrix. The element Aij in the matrix A belongs to ith row and jth column. Aij meaning is the element of the matrix is to ith row and jth column of a matrix. Okay. Next, types of matrix. Row matrix. What is row matrix? A matrix is said to be a row matrix if it has only one row and any number of columns. A matrix is said to be a row matrix if it has only one row and any number of columns. See one example here. A matrix. This is 1, 2, 3, 4. This is one matrix. How many rows are there? There is only one row. And how many columns are there? 1, 2, 3, 4. 4 columns. A matrix is said to be a row matrix if it has only one row and any number of columns. So 1 by 4, this is a matrix order. Column matrix. A matrix is said to be column matrix. It has only one column and any number of rows. See the example. Example A, B, C, D. Here, how many rows are there? There are 4 rows and 1 column. A matrix is said to be column matrix if it has only one column and any number of rows. So this is called column matrix. Singleton matrix. If in a matrix there is only one element, then it's called singleton matrix. For suppose, see one example, B is equal to -1. This is singleton matrix. What is order of the matrix? One row, one column. This is order of the matrix. C 1, or you can take only 0. This is also singleton matrix. Matrix order is 1 by 1. Only one element is there means that matrix we will say that singleton matrix. Okay, so I'm going to another definition. Null matrix or zero matrix. In a matrix all the elements are zeros, then it is called a zero matrix or null matrix. It is denoted by O. A is equal to Aij m by n is a zero matrix if Aij is equal to 0 for all I and j. That means each and every element in a matrix 0 means we will say that that is null matrix. Now see the students, 0 0 0 0 0 0 0 0 0 0 0 0. Each and every element is 0 means we will say that null matrix. How many number of rows are there here? There are 3 rows, 4 columns. Order of the matrix, how much? 3 by 4. It is denoted by O, null matrix. O 3 by 4 means null matrix, order 3 by 4. Okay, students. Next, rectangular matrix. In a matrix, if the number of rows is not equal to number of columns. Number of columns, both are not equal means we will say that such matrix is rectangular matrix. Number of rows and number of columns equal means that matrix we will say that square matrix. For example, see here A matrix I am taking. So this is example 1 2 3 4. 1 2 3 4. This is a matrix. How many number of rows are there? There are 2 rows and 4 columns. So here rows is not equal to columns. Rows not equal to columns. Number of rows is not equal to number of columns means that is rectangular matrix. Next I am going to square matrix. See here 1 2 3 4 5 6 7 8 9. This is a matrix. How many number of rows are there? There are 3 rows and 3 columns. See here 3 is equal to 3 or not? Number of rows is equal to number of columns. That matrix we will say that square matrix. If number of rows is not equal to number of columns means rectangular matrix. Next, principal diagonal of a square matrix. Principal diagonal of a square matrix. See here, square matrix. In a square matrix, the diagonals from first element of the first row to the last element of the last row is called the principal diagonal of the square matrix. For suppose I am taking the one square matrix 1 2 3 4 5 6 7 8 9. This is square matrix. So what are the Principal diagonal of a square means the first element of the first row to the last element of the last row. These elements, we will say that principal diagonal elements. Generally, we know that for suppose this is a square, how many diagonals are there? This is one diagonal, this is another diagonal. Here also one more diagonal is there, 7, 5, 3. This is another diagonal. But only one is specific name is set, that is principal diagonal element. That is first row first element to the last row last element. These elements are included means this is, we will say that these elements are, we will say that principal diagonal of a square matrix. Okay. Next, diagonal matrix. What is diagonal matrix? A square matrix, if all the elements outside the principal diagonal are zero. That means except principal diagonal elements, each and every element is zero means such square matrix, we will say that diagonal matrix. Okay. Now take one example. For suppose a matrix. Now I am going to take some elements 1, 0, 0, 0, 2, 0, 0, 0, 0. Here see that except principal diagonal elements, each and every element is zero means we will say that that is diagonal matrix. Diagonal matrix. So here already we are taken zero, no problem. At least one of the element in principal diagonal elements not equal to zero. So we can take in place of 2, 0. So this is diagonal matrix only. If in place of 1, for suppose you are taken 0 means this is null matrix. This is null matrix. So finally what I am saying, null matrix is also diagonal matrix only. Null matrix is also diagonal matrix only. So finally what I am saying means except principal diagonal elements, each and every element is zero means we will say that that is diagonal matrix. For suppose a matrix, they are given like this 1, 0, 0, 0, 5, 0, 0, 0, 9. Then what is a power n or a square, a cube, a power 4? This is a formula. 1 power n 0, 0, 0, 5 power n 0, 0, 0, 9 power n. This is diagonal matrix. This is, we can write another form also. A is equal to diagonal means DIAG of 1 comma 5 comma 9. That meaning is the matrix having principal diagonal elements 1, 5, 9. Other elements are 0. Okay. So diagonal matrix we can write in this form also. Both are same. Both are same. Here note is there. Please copy this. If A is equal to diagonal of D1, D2, D3 and so on Dn, then A power n is equal to diagonal D1 power n, D2 power n, D3 power n and so on Dn power n. Okay, this is an important concept in object. Next, identity matrix or unit matrix. A square matrix in which each element in the principal diagonal is 1. Each element in the principal diagonal is 1. Rest are all zeros. It's called identity matrix or unit matrix. Okay. Now I will give an example. See the students. A is equal to 1, 0, 0, 1. Next, B is equal to 1, 0, 0, 0, 1, 0, 0, 0, 1. This is 3 by 3 matrix. This is 2 by 2 matrix. Identity matrix is denoted by I. So here we can write I, 2 by 2 matrix. So second matrix also we can write I, 3 by 3 matrix. Students, are you understood? Except principal diagonal elements, each and every element is 0, and all principal diagonal elements are equal to 1. Equal to 1. So here one condition given. See this, Aij value 1. If I is equal to j, if I not equal to j is 0. This is a condition. So how to use that? For suppose A matrix, I am writing like this. A11, A12, A13, A21, A22, A23, A31, A32, A33. This is 32. Here observe that I is equal to j. In suffix, whatever is there, both elements are equal. This should be 1. This should be 1. Remaining, each and every element is 0. That means this is, we can write 1, 0, 0, 0, 1, 0, 0, 0, 1. This is identity matrix order 3 by 3. That is the meaning of this. Okay. So identity matrix is denoted by I. Identity matrix order n is denoted by in, order 3, I3, order 2, I2, we can write. Okay, students. Next, scalar matrix. What is scalar matrix? A square matrix whose all non-diagonal elements are 0 and diagonal elements are equal to some scalar. Equal to some scalar. It's called a scalar matrix. See, 5, 5, sorry, 0, 0, 0, 5, 0, 0, 0, 5. See here, principal diagonal elements are all equal to some scalar. Unit matrix also, that is scalar matrix only. The principal diagonal elements are equal to scalar, one or not, but all elements are equal to 1 means we are putting one separate name, that is identity matrix. Other than 1, we can say that is scalar matrix. So this is, remember it, Aij value, I is equal to j, alpha, I not equal to j, 0. So other than principal diagonal elements, each and every element is 0, and the principal diagonal elements are equal to scalar. Then we will say that such matrix is scalar matrix. What is order of this matrix? 3 by 3. Okay. So note this important. Unit matrix and null matrix, null square matrices are also scalar matrices only. Unit matrix, null square matrices are also scalar matrices. Okay. Next, triangular matrix. What is triangular matrix? Triangular matrices are two types. One is upper triangular matrix. Another one is lower triangular matrix. A square matrix Aij is said to be triangular matrix if each element above or below the principal diagonal, above or below principal diagonal is 0. It is of two types. It is of two types. Upper triangular matrix. A square matrix Aij is called upper triangular matrix if Aij is equal to 0 where I greater than j. This is a mathematical, but in generally we can say that below the principal diagonal elements, each and every element is 0 means we will say that upper triangular matrix. See, 1, 2, 3, 4, 5, 6, 0, 0, 0. See here, below the principal diagonal elements, these are principal diagonal elements. Below the principal diagonal elements, each and every element is 0 means we will say that upper triangular matrix. But lower triangular matrix, here one condition given. If Aij is equal to 0 when I less than j. So I am going to write example. Above the principal diagonal elements, each and every element is 0 means we will say that upper triangular matrix. Now see the example, then you will understand. 0, 0, 0. Okay, this is a matrix. See here, these are the principal diagonal elements. Above the principal diagonal element, each and every element is 0 means each and every element is 0 means we will say that that matrix is lower triangular matrix. Okay. Next, I am going to trace of matrix. What is trace of matrix? The sum of diagonal elements of a square matrix. The sum of principal diagonal elements of a square matrix is called trace of matrix. It is denoted by trace of A. Trace is also called as spur. Okay. Now see one example, then you will understand. This is a matrix. 1, 2, 3, 4, 5, 6, 7, 8, 9. What are the principal diagonal elements here? These are the principal diagonal elements. Trace of matrix they are asking. Trace of A. Trace of A means sum of principal diagonal elements. Sum of principal diagonal elements. Diagonal elements. What are the principal diagonal elements here? 1 plus 5 plus 9. Total how much, students? This is 15. So in this matrix, trace of A is how much? 15. 15. Students, are you understood now? Here some properties are there. Some properties are there. 1 second. Properties of trace of matrix. A and B, two matrices, and lambda be a scalar if trace of lambda A that is equal to lambda into trace of A, where lambda is scalar, remember it. Okay, so I'll write here one example. Trace of 2A. A is the matrix, so that is we can write 2 into trace of A. Whatever is there, constant term, right outside. Okay. Next, trace of A plus R minus B. Either A plus B or A minus B, whatever may be. We get trace of A plus R minus trace of B. Trace of AB is equal to trace of BA. Trace of identity matrix order n, that is equal to n only. Now students, tell me, trace of identity matrix order 9, what is answer? That is 9 only. For suppose identity matrix 3 by 3 matrix, 0 1 0 0 0 1 0 0 0 1. This is 3 by 3 matrix. Then what is trace of matrix? Sum of principal diagonal elements. Right here. Trace of A. Trace of A, how much? 3. This is 3 by 3 matrix. That's why we are getting 3. N by N matrix means we will get N. 9 by 9 matrix means we get sum 9. Okay. I think are you understood now? So I'm going to another property. Trace of AB is not equal to trace of A into trace of B. Trace of AB is equal to trace of BA, but trace of AB is not equal to trace of A into trace of B. Okay. If A, B, C are square matrices of order n, square matrices, remember it. Trace of ABC is equal to trace of BCA is equal to trace of CAB, ABC, BCA, CAB. After multiplying the three matrices, trace will get same. Trace will get same. I'm going to equality of matrices. When the two matrices are equal, two matrices having same order and the corresponding elements of A and B are equal. Same type or order, the corresponding elements of A and B are equal. Then we will say that the two matrices A and B are equal. When the two matrices are equal, two matrices having the same order and the corresponding elements are equal. For suppose see here, A is equal to A, B, C, D. This is one matrix, 2 by 2 matrix. Next, take the B matrix. B matrix 1, 2, 3, 4. This is also 2 by 2 matrix. The two matrices having same order. Okay, first condition is satisfied. Then what about second condition? The corresponding elements are equal. A is equal to 1, B is equal to, C is equal to 3, D is equal to 4. These values are equal to 1, 2, 3, 4 means A1, B2, C3, D4. Then we will say that A and B are equal matrices. Okay. Addition of two matrices. Already you know that if A and B are two matrices of the same order, then their sum denoted by A plus B. How to add the two matrices means two matrices having the same order and add the corresponding elements. For suppose these are the two matrices, I am going to add now A plus B. How to add, students, tell me? A plus 1, next B plus 2, next C plus 3, next D plus 4. This is addition of two matrices. The two matrices having same order. Now add the corresponding elements. And difference, subtraction of two matrices, same like that. The two matrices having same order and subtract the corresponding elements. Okay, right. Next, properties of matrices in addition. A plus B is equal to B plus C. That is commutative law. A plus B plus C is equal to A plus B plus C. Associative law in addition. A plus 0 is equal to 0 plus A, that is equal to A. O is the zero matrix, which is called additive identity. O is called additive identity. A plus minus A is equal to 0. Minus A plus A is equal to 0. Where minus A is obtained by changing the sign of every